And welcome to another Algebra 1 video tutorial. In lesson 12.5 we will be factoring ax squared plus bx plus c. So our goal will be to factor a quadratic expression in which the coefficient of the square term is not 1. In section 4 we did not have a coefficient here that was not 1. It was always 1x squared. Now we're going to get something that's not 1x squared. So it's a little more complicated factoring, but similar to lesson 4. So the big idea would be to say some quadratic trinomials of the form ax squared plus bx plus c can be factored into two linear factors. And there's some that can't be factored. Today we'll only look at ones that will be factored. Alright, factor 50x to the fifth plus 200x to the fourth plus 200x cubed. Now this one isn't of the form ax squared, so we need to take a GCF out first. Okay, so that's going to be what can happen. So the GCF in this case is going to be 50. Now they have x to the fifth, x to the fourth, x cubed, so we can take out 50x cubed. When we do that, we're going to get x squared plus 4x plus 4. Okay, now this is of the form from the other day, so we got this down to where it's 1x squared. This can factor into two binomials as x plus 2 times the quantity x plus 2. So we have 50x cubed times the quantity x plus 2 times the quantity x plus 2, because we're looking at the factors of 4 that add up to 4, so it'll be 2 and 2. Now this could also be written as 50x cubed times the quantity x plus 2 squared. Alright, now when the coefficient of the square term is not 1 and there's no common factor of the three terms like we just looked at, a different process is going to be applied. So suppose ax squared plus bx plus c can be factored into dx plus e times the quantity fx plus g. Now the d and the f, so the product of d and f would be the a. So we need to now look at what makes a x squared. So we need the product of d and f to be a, and then we also need the product of e and g to give us c. Now the task is to make sure we can get d, e, f, and g so that the rest of the multiplication and addition gives us b. So it's kind of a sort of a guess and check, but if you kind of have an idea of these front two, the d and the f, would multiply to be a. The last two in each, e and g, would multiply to be c, and a combination of all those multiplications and additions is going to add up to b, and that's the task, or the hard part here. Alright, so factor 5x squared plus 32x plus 12. Now we know the nice thing about 5x squared is it has to be 5x and 1x, as the only factors of 5 are 1 and 5. Now 12, the factors of 12 are 1 and 12, 2 and 6 are 3 and 4, and they're all going to be plus and plus, positive and positive. So let's use one of these factor squares to get this to work out. So 5x and x, that's going to give us 5x squared. Now we need to get 12, and then after multiplying and adding, we need to end up with 32. So remember, we can use 1 and 12, we could use 2 and 6, or 3 and 4, and they can go any combination here. But remember, we got to get 32x. So one of these, this down here is a width of 5x, so this term down here gets multiplied by 5, so opposite of the 5. Okay, so we could try 1 and 12. So let's go 1 and 12. So this is going to be a 12 by x. This is going to be a 5 by 1. So those only add up to 17. So if we put 12 down here, we're going to get 5 times 12, which is 60. So that puts us way too much. So it's not 1 and 12. So let's try 2 and 6. So it's not 1 and 12. 2 and 6. Now, if I put 2 down here, I'm going to get 10. Over here, I'm going to get 6. That's not enough. So let's put the 6 down here because I need it opposite of the 5. So 5x times 6, that's 30x. And over here would be plus 2. 2 times x. 30x and 2x make 32x. So this has to work. So it's going to be 5x plus 2 and x plus 6. If we would have went to 3 and 4, that and none of those combinations would have worked. So this factors into the quantity 5x plus 2 times the quantity x plus 6. And that's the only way that will factor with linear factors and integer factors. All right, factor 15y squared minus 16y minus 7. Okay, so now this front term isn't set in stone because it could be 1 and 15 or 3 and 5, and I usually start in the middle when I'm guessing on this. So let's start with 5y and 3y. Okay, so that's going to give us 15y squared. Now the nice thing about multiplying to be negative 7 is it can only be 1 and negative 7 or negative 1 and positive 7, but they could go in either spot here. Okay, so let's try putting the negative 7 down here and the positive 1 up here. So this is going to give us 3y. This will give us negative 35y, and that is not going to work. Negative 35y plus 3y, that's negative 32y. So that's not going to work. Okay, so we would cross that scenario off. Okay, let's try something different. Let's try the negative 7 here and the 1 here. So switch spots. So 3y times negative 7y, or just times negative 7, that's going to give us negative 21y. And down here, 5y times 1, so that's 5y. Now, 5y and negative 21y, that's what we needed, was negative 16y. So this is the factor. So it's 5y minus 7, and then 3y and a plus 1. So 3y plus 1. So that is factored from this. Now, we can also use this to solve, so besides using the quadratic formula, if we have this factored, so write its equivalent in factored form, 5y minus 7 times the quantity 3y plus 1, set that equal to 0. So instead of using a, b, and c, we can use the zero product property, and now we can say, all right, well, if this quantity is 0, what y value makes this quantity 0? And then it would make this 0, and vice versa. 3y plus 1, what makes that 0? So I just say, all right, well, when does 5y minus 7 equals 0? So add 7, divide by 5, so y equals 7/5. Or when does 3y plus 1 equals 0? Well, subtract 1 from both sides, and then divide by 3, so y equals negative 1/3. So that's how you could solve this if it was equal to 0, if you had factored form rather than running through the quadratic formula. Alright, so let's factor 35x to the fourth plus 35x cubed minus 420x squared. This is one of those that's going to have a GCF that we can take out first. So if we do that, they all have in common a 35 x to the fourth, x cubed, x squared. So they all have a 35x squared in common. So what happens when we factor that out with the monomial factoring? We're going to be left with x squared plus x minus 12. Okay, then we need to factor this one more time, and we get 35x squared. This would have to be x and x. Now, since this is 1x squared, x and x, 1, 1, so that means that we can just look at the factors of negative 12 that add up to a positive 1. So that means they're only, one's positive, one's negative. That's the only way to get to multiply b, negative 12, and add up to a positive 1. Well, it'd have to be a plus 4 and a minus 3, and this would be the factored form of 35x to the fourth plus 35x cubed minus 420x squared. All right, number 2, factor 7x squared minus 33x minus 10. Let's try a factor square here. And the nice thing about 7x squared is it can only be 7x and 1x. So we know that part for sure. Now we need to get negative 10. So that means we could be 2 and negative 5, negative 2, positive 5. It could be 1 and negative 10 or negative 1 and positive 10. And which way will it be? Well, I know that 7 times negative 5 is negative 35, and then x times 2. So that's going to give us the negative 33. So the minus 5 needs to be opposite of the 7. So it needs to be down here. So it should be x minus 5, and over here should be 7x plus 2. Because this is a 2 by x, this is a 7x by negative 5, so it's negative 35x. And you can see how you can kind of, you know all the factors, but you don't have to try them all if you kind of know that they need to add up to negative 33 after some multiplication and addition. Okay, so it should be 7x plus 2 times the quantity over this side would be x minus 5. And that's the only combination that works in factored form. All right, number 3, factor 6z squared plus 13z minus 5. And let's try factor square. Now, I don't know if it's 1 and 6 or if it's 2 and 3. I usually start with 2 and 3 rather than the 1 and 6 for whatever reason, and it's not one right way or another. So let's try 3z and 2z. That will give me 6z squared. Now, the reason I like negative 5 is because it could only be 1 and negative 5 or negative 1 and positive 5. And which way will it be? Well, 3 times 5 is 15. So I think the 5, the positive, and it ends up being positive 13. So I think the positive 5 needs to be opposite of the 3. So that means the minus 1 would have to go over here. Now, 3z times 5 is 15z. Over here it's a negative 1 by 2z, so that would be negative 2z, and those two will add up to 13. This bottom right corner will be negative 5. So that's the factored form we want. The quantity 3z minus 1 times the quantity 2z plus 5. All right, now another one of those. Let's solve it equal to 0. So let's put it in factored form. Is what we just did to begin with. So we'd have 3z minus 1 times the quantity 2z plus 5 equals 0, and use the zero product property. So when does 3z minus 1, some of you are going to see that quickly mentally, but I'll show you how you do that mentally. You'd add 1 and divide by 3, right? Add 1, divide by 3. So z equals 1/3. This other one, you're going to subtract 5 and divide by 2, so negative 5 halves. But I will write it out as well for you. 2z plus 5 equals 0. Minus 5. Divide by 2. So z equals negative 5 halves. If we had this equal to 0. Now, the quadratic formula will always work, but we can also see that factored form and the zero product property works pretty handy as well. All right, your assignment will be 12-5, page 745, number 2 through 24 evens. Thanks for tuning in, and we'll see you next time.